In this video, we're going to prove that if y equals sine x, then dy dx equals cosine x. In other words, the derivative of the sine function is the cosine function. Well, there's some prerequisite knowledge. Number one is from trigonometry. It says that the sine of a plus b is equal to the sine of a times the cosine of b plus the sine of b times the cosine of a. Number two is a limit. The limit as x tends to 0 of cosine x minus 1 over x equals 0. This is proven in using a method similar to the way that we proved that the limit of sine x over x as x tends to 0 is 1. Anyway, here is the proof. We use the limit definition of the derivative and state that dy over dx is equal to the limit as delta x tends to 0 of sine x plus delta x minus sine x over delta x. Now the sine of x plus delta x can be broken down using this trig identity. So we now have the limit as delta x tends to 0 of sine x cosine delta x plus sine delta x cosine x minus sine x over delta x. Now what I want to do is I want to join this term, the sine x, up with the sine x cosine delta x, and I'm going to factor out the sine x. I also split this limit up into two limits. So I've got the limit as delta x tends to 0 of the sine of x cosine delta x minus sine x all over delta x, and then I've got plus the limit of the rest of it, sine delta x cosine x over delta x as delta x tends to 0, and I rewrote it just a little bit. So now what I did was I factored out a sine of x, leaving cosine delta x minus 1, and since the only thing that's changing is delta x, x is can be thought of as a constant, and the sine of x can be thought of as a constant, and it can come outside the limit. The same with this cosine of x over here. It can come outside. Well, now we've got sine of x times this limit, which we are assuming is 0, and then we've got the cosine times this limit, which we have already shown is 1. So we get sine of x times 0 plus cosine of x times 1 equals cosine x.